Now we want to find the area using limits. So this will give us the exact area. Let's take the region bound by f of x equal to x cubed. That's the green line here. The x-axis, and the vertical lines x equals 0 and x equal 2. So this is the region we're trying to find the exact area of. First of all, notice that a equals 0 and b equals 2 are the endpoints for our x values. So we take 2 minus 0 over n, which gives us 2 over n. So if we look at right endpoints, our first interval ends at 2 over n, our second one ends at 2 times 2 over n, our next one is 3 times 2 over n. So in general we have 2I over n. So to find the area that we're looking at, we take the limit as n approaches infinity, the summation of f of c sub I goes from 1 to infinity, I goes from 1 to n of delta x. So our f of c sub I, we're going to take this expression and put it into our equation. So we take the limit as n approaches infinity, summation of 2I over n to the third power times delta x, which is 2 over n. I goes from 1 to n. So notice we can factor out the n terms from here because they're not affected by the I term. So we wind up with the limit as n approaches infinity, 16 over n to the fourth times the summation of I cubed. That goes from 1 to n. We have a formula that replaces this that we can use. So we take 16 over n to the fourth times n squared, n plus 1 squared, all over 4. Notice here 16 and 4 cancel, so we're left with the limit as n approaches infinity of n squared times n squared plus 2n plus 1 all over n to the fourth, and we have a 4 here. Now as we take this limit, the only important term is the highest power term, so we take 4n to the fourth over n to the fourth, and our result is 4. So the area under the curve from 0 to 2 of y equals x cubed, the exact area will be 4.